Today we are starting with a new topic, that is star delta conversion, and this deals with only the resistive circuit. Will not be connecting any voltage or the current sources. So since we are not connecting any voltage, we'll not be looking at the current flow also. So it's just dealing with the resistance or the capacitive or inductive reactances. Fine. There are some circuits which are neither in series or nor in parallel connection. Okay, I'll be introducing you to such examples. Before that, just look at this. Okay, this is delta. This is called as delta circuit. Why it is called as delta circuit? Because this is in the shape of delta. Okay, sometimes this can also be called as pi network. Why it can be called as pi network? See the same delta here. What you're seeing, same delta can be connected like this. See here. Okay, so the same circuit can be looked at like this sometimes. Okay, so this is depending on how they are, we call them as delta or pi. Fine. So this delta network can be converted into a star type of network. What is that star type of network? See here. This is a star network. Fine. Now we should also observe that this delta network has got three resistors, R1, R2, R3. Fine. And see, R1 is between the 2 points A, C, R2 is between A and B, R3 is between B and C. Okay. Now see here, this is A, B, C. What you can see is, say, suppose we have a delta network, we can get a star. The dotted path, dotted lines, what I'm showing, that's a star network. Okay, so that star network is what I'm showing you here. Fine. So from point A, what is coming out is referred to as RA. Okay, from point B, the resistor which is coming from point B is referred to as RB. Okay, and this obviously is RC. So this is delta, and this is star. So what we are looking at is, suppose a delta is given, how to obtain a star. Suppose a delta is given, how to obtain a star. Okay, so that means delta is given means what, which resistors are given, R1, R2, R3 are given, they are available. Okay, with R1, R2 available, R1, R2, R3 available, how can I obtain RA, RB, RC is the question. Because I have to obtain a star out of the delta. Delta deals with R1, R2, R3. Star deals with RA, RB, RC, for your understanding. Get that point? Now, which means that I need to obtain RA, RB, RC in terms of R1, R2, R3. How is that is going to look like? See here, R1, R2, R3 is given because we are converting delta into star. So that means I need to be obtaining RA, okay, RB, and RC. I need to obtain these three resistors. Everybody just observe here. Now this RA is coming from this point, right? So on both sides of RA, suppose this is RA. Suppose this is RA. On both sides of RA, which resistors are available? R1 and R2 are available, right? So it's R1, R2 divided by R1 plus R2 plus R3. This is your resistor RA. Everybody get that point? Similarly, what is RB? This is RB. See, here is your RB. Suppose I want to obtain RB means here is your RB. On both sides of RB, which two resistors are there? R2 and R3, right? So RB is R2, R3 divided by sum of all the resistors R1, R2 plus R3. Similarly, what is going to be your RC? What is going to be your RC? Okay, RC would be here. Okay, so can you write RC yourselves? What is RC? See here, on both sides of RC you have R1 and R3. So R1, R3 in the numerator divided by R1 plus R2 plus R3, sum of all the resistance in the denominator. So this is how we can convert a delta into star. Everybody is okay with that? Now we shall see how RA, RB, RC can be written as these. Okay, so we shall see how we can obtain the equations for RA, RB, RC. Okay, this proof is sometimes asked. Okay, derive the equations for RA, RB, RC given the delta like this. Understand that? So let's see the proof now. So this is what we have to obtain. This is what we have to obtain. Okay, when you are asked to convert delta into star, this is what we have to obtain. Okay, so you have to prove now. This you have to prove. Understand? Now let's consider 2 points here. AB. Let's consider 2 points AB. Fine. Now suppose I want to obtain the resistance across the terminals AB. You understand what I mean? Suppose I want to obtain the resistance across the terminals AB. What would that be equal to? Everybody just observe. You need not have to write anything, just observe. Okay, I've taken this. Here is A. Fine. Now, what I'm telling you is, let's extend these. Okay, so this is terminal A and this is terminal B. So what is being asked? What is RAB across points AB is what is being asked. Or we can just do this. Looking into terminals AB, what is RAB? So we can write this in this format. Everybody just observe. Okay, see here. Suppose this is A and B, this would be your C. Okay, if this is your C, what is between A and B? R2 is there. Okay, between A and C, this is also A. Between A and C, R1 is there. Between B and C, R3 is there. Okay, so can you now give me what is RAB? How R1, R3 are connected? See, this C is of no importance to us. AB is of importance to me. C is not of any importance to me now. Get that point? C is not of any importance. Fine. So this means that this implies that R1 and R3 are in series. Okay. So this series combination is in parallel with R2. Everybody is okay with that? So we can write RAB as, we can write RAB as R2 in parallel with what? R1 plus R3. Is this understood, everybody? There is a resistor R2 which is in parallel with the series combination of R1 and R3. Get that point? Now, what would this be? So this would be, therefore, our RAB would be what? It's R2 into R1 plus R3 divided by R2 plus R1 plus R3. So this is your RAB obtained from delta. Is this okay with you? So let's say consider the delta, and obtain RAB. Similarly, consider, now let's just see what I'm doing. Everybody just look at. Consider now what is asked to be considered is this. Let's consider the star. Okay, this is A, B, and C. This is RA, RB, and RC. Okay, now between these two, you need the resistance across terminals AB. Okay, so what would happen to this C then? This C is redundant. When I'm finding the RAB, the resistance across AB, keeping star into consideration, RC is of no use to me. So how does it look like? The circuit actually looks like this. See? Okay, so this is how the circuit is going to look like. What is this? This is A and this is B. Okay, so the C, this is redundant, so I'm not taking this into consideration. So you have RA and you have RB. Get this point, everybody? So this branch being redundant, I'm not considering that when I'm writing RAB. So RAB is what now? What is RAB? So therefore, from star, RAB is actually equal to what? RA plus RB. Is this okay with you, everybody? Yes. Since delta and star are equivalents, okay, you can say that. Call this as equation number 2. Call this as equation number 2. Since, make a statement, since star and delta are equivalents, equation 1 is actually equal to equation 2. Okay, so RAB that we have got from star is equal to RAB that we have got from delta. Okay, so this implies what? This implies R2 into R1 plus R3 divided by R2 plus R1 plus R3 is actually equal to RA plus RB. Okay, call this as equation 3. Is this understood, everybody? Okay, what we have done, we have taken a delta. Okay, we have taken a delta, and from delta we got the equation for the resistor RAB, resistance across terminals AB. We considered star, okay, and got the equation for the resistance RAB. Okay, when we are doing that with star, RC becomes redundant, so we neglect that. So it's redundant, so we neglect that. So RAB happens to be RA plus RB. Since these two are equivalents, these two are equal. If you are given delta, I'll give you star. If you give me star, I'll give you delta. Okay, so in that sense, they are equivalents. So since they are equivalents, equation 1 and 2 are same actually. So therefore, we can have this. Is that okay with you? Okay. Similarly, we can have. Similarly, you can deal with the other two terminals. Okay. Similarly, R3 into R2 plus R1 is divided by what? R3 plus R2 plus R1 equal to what? Okay, so this would be equal to RB plus R. So if you want to just see that, it's R2 is outside, right? So R2 is out. R2 into R1 plus R3 is equal to what? RA plus RB. R2 into R1 plus R3 is RA plus RB. Let me keep it like this. R2, if we are looking into AB, it's R2 into R1 plus R3 divided by R1 plus R2 plus R3 is equal to RA plus RB. Similarly, can you give me, if we are looking into terminals AC, if you are looking into terminals AC, what? Or suppose you are looking into terminals BC, what would you write it? It's R3 into R1 plus R2 divided by R1 plus R2 plus R3 is equal to what? RC plus RB. Is that okay with you, everybody? So once you obtain this, once you obtain equation 3, on similar grounds, we can obtain the other two equations. Okay, so this equation 3 is obtained looking into terminals AB. If you look into terminals AB, okay, if you look into terminals AB, in this direction, if you look, okay, it is R2 into R1 plus R3 divided by sum of the resistances, that is equal to RA/RB. If you look into terminals BC, it's R3 into R1 plus R2 divided by sum of the resistance, that's equal to RB plus RC. Okay, so that is how we have been doing that. Okay, so similarly, you need not have to do this again. Just say similarly, on similar grounds, we can obtain this equation number 4 and equation number 5. What is that? R1 R2 plus R3, okay, divided by R1 plus R2 plus R3 would give you what? R1 means we are looking into terminals AC. R1 means where is AC? Okay, RA plus RC. It's RA plus RC. So this is equation number 5. So I hope you have understood how we obtained equation 3, 4, 5. We have done detailed steps to get equation 3. On similar grounds, we can obtain equation 4 and equation 5 also. Get that point? Now, from 3, 4, 5, we have to try get the equation for RA. Understand that? From 3, 4, 5, we have to get the equation for RA. Manipulate, do anything. Okay, but get me the equation for RA. Okay, so let's do that now. To find RA, what we do is this. See here, you have equation 3 and equation 4, right? Okay, from 3 and 4, what let's eliminate this RB. Let's do 3 minus 4. Equation 3 minus equation 4. Everybody do 3 minus 4. Equation 3 minus equation 4 implies what? Everybody do that. Equation 3 minus equation 4 is R1 R2 plus R2 R3 divided by, so minus R2 R3 minus R1 R3 divided by R1 plus R2 plus R3. Taking the LCM, I've done that. For both, the LCM is same. Okay, this minus this I'm doing. The numerator would also be same. Okay, on the right hand side, what you would have RA plus RB minus RB minus RC. So if you subtract 3 minus 4, if you do 3 minus 4 on the right hand side, what would be left? You'll be left with RA minus RC. Okay, see, there is R2 R3 plus R2 R3 and minus R2 R3 here. So we end up getting what? We end up getting R1 R2 minus R1 R3 divided by R1 plus R2 plus R3 is equal to RA minus RC. Call this as equation number 6. I need RA. What we are trying to find out is RA. Okay. So what you can do, can you just see equation 5 and 6 and see how we can retain RA by eliminating RC? How we can eliminate RC? We can eliminate RC by adding these two equations. Okay. So let's not bother what is happening on the left hand side. Let's bother about retaining RA and eliminating RB and RC. Okay, what we are trying to obtain is RA in terms of R1, R2, R3. So how to retain RA? By adding 5 and 6. So 5 and 6 now. 5 plus 6. 5 plus 6 gives you what? Everybody see what does that give us? So it's R1, R2 plus R1, R3. Okay, plus R1 R2 minus R1 R3, okay, divided by R1 plus R2 plus R3. Yes, R1 plus R2 plus R3, and on the right hand side you will have 2 RA plus RC minus RC goes off. So R1 R3 is there, right? So these two will go off. So what remains there? What remains there? What remains is this 2 R1 R2 divided by R1 plus R2 plus R3 would give you 2 RA, okay, which implies that RA is R1 R2 divided by R1 plus R2 plus R3. This is how we can obtain our RA. Okay, so that is the equation we had got earlier. See, RA is, what is RA? RA is here, it's R1 R2 divided by sum of all the resistors. Similarly, RB and RC you can obtain. Just let's write that. Similarly, you can just write that at the end. One equation you have obtained, you can just say on similar grounds we can obtain our RB equal to what? R2 R3 divided by R1 plus R2 plus R3. The denominator is same. RB is R2 R3. Let's see again. RB is R2 R3. Exactly. Then RC is R1, R3. Okay. So this is one equation that you can obtain on similar grounds. You're not doing it again. You'll just say similarly. Okay. RC would be R1, R3 divided by R1 plus R2 plus R3. So this is how one can derive the equations for RA, RB, RC. That means if you're asked to convert delta into star, if you're asked to convert delta into star, delta to star conversion, then you have to obtain RA, RB, RC in terms of R1, R2, R3. Okay, so this is how it is done. Okay, now we shall see how to go about star to delta. What we have done is delta to star. Now we shall see star to delta. Okay, everybody copy this. Star to delta conversion. Star to delta conversion. So star to delta conversion means we need to have star with us. Okay, that is this. Okay, so A, B, and C. If this is A, this is RA, this is RB, and this is RC. So star is given. We need to obtain a delta. See, we need to obtain this. Okay, so this is A, B, C. So this is our R1, R2, and R3. So what is that we are obtaining? See the dotted path we are obtaining. Dotted path we are obtaining. Given star, this dotted path we are obtaining is delta will obtain. So this is our R1, R2, and R3. I'll give the equations. Let's obtain those equations after the proof. Okay, what is that equation that we need to have? Now, you'll be given RA, RB, RC. You have to obtain R1, R2, R3. What is that? See here, everybody. Your R1 would be in the numerator. In the numerator, you will have sum of all the products. Sum of the products. That is means RA, RB plus RB, RC plus RC, RA. So in the numerator, you will have this. In the numerator of all R1, R2, R3, you will have this. In the denominator, what you will have? See, R1 is here, right? So you see opposite to this. Vertically to this line. R1 is there, right? Vertical to this line. What is there? RB is there, right? So that register would come in the denominator. Is everybody okay with this? Now, similarly, can you tell me what is R2? Again, what is there in the numerator is same. RA, RB, RC plus RC, RA. This is same. What would be there in the denominator? Suppose if you are writing R2, where is R2? R2 is here. Okay. So which register is standing vertical to this? RC. So that would come in the denominator. On the similar grounds, we can write our R3 equal to this. Divided by RA, because you are looking at R3, right? So RA stands perpendicular to that. Okay, so this we need to prove. This we need to prove. Okay, so how to prove that is this is quite simple. So this is extension of what we have done previously. So we'll just say we know that, everybody just take down that we know that our RA is R1 R2 divided by R1 plus R2 plus R3. RB is equal to R2 R3. This is something that we have obtained in previous step. So what we're doing is just the extension of that. RC would be R1 R3 divided by R1 plus R2 plus R. So this we know. So when do we obtain this? When delta is given, we obtain star like this. Okay. So let's call them as equation 1, 2, and 3. Okay. Now perform 1 equation 1 into 2, 2 into 3, and 1 into 3. Equation 1 into 3. So what do we obtain? We obtain 3 more equations. Okay. How do they look like? RA into RB is what we get from 1 into 2. So RA, RB. If you multiply the right hand sides, what you'll be getting? You'll be getting R1 into R2 square R3 divided by R1 plus R2 plus R3 whole square. So this is one equation we get. Okay, call it as let's say call this as equation number 4. Similarly, 2 into 3. What would 2 into 3 give you? 2 into 3 gives you this. RB into RC. RB into RC would give you R1, R2, R3 square. This is square. In the denominator, there should be square. Okay. So divided by R1 plus R2 plus R3 whole square. Okay. Call this as 5. Similarly, our RA, RC would be R1 square, R2, R3 divided by R1 plus R2 plus R3 whole square. Call this as equation number 6. So we obtained 4, 5, 6 by multiplying 1, 2, 2, 3 and 1, 1, 3. Understand this? Now add these products. Why do we need to add these products? Why do we need to add these products? Tell me. Because we're looking at RA, RB, RC, RA, RB plus RB, RC plus RC, RA to be there, right? So how we can obtain that? By adding these 3. Okay, so let's add equation 4, 5 and 6. So 4 plus 5 plus 6 would imply RA, RB plus RB, RC plus RC, RA or RA, RC equal to what? Equal to the denominator is same. Okay, so what you would have is this R1, R2 square R3 plus R1, R2 R3 square plus R1 square R2 R3. Because the denominator is same, the LCM you take, you will find this. Okay, so R1 plus R2 plus R3 whole square. So what we shall do next is this. See in this equation, let's take in the numerator, let's take R1, R2, R3 common. If you take R1, R2, R3 common, what will be left? R2 plus R3 plus R1 would be left. Okay, in the bracket. So in the denominator, we have R1 plus R2 plus R3 square. So what happens? This and this goes off. This and this goes off. Okay, so one term will go off. So you'll be left with what? You'll be left with R1, R2, R3 divided by R1 plus R2 plus R3. What is this? This is RA, RB plus RB, RC plus RC, RA. Okay, now what is this? Can you make out? What is this? R1, R2 divided by R1 plus R2 plus R3. What is that? See here. R1, R2 divided by R1 plus, that is RA, isn't it? So this being RA. So this is RA, isn't it? So therefore, what is R3? So therefore, we can write R3 as RA, RB plus RB, RC plus RC, RA divided by RA. Get that point? So with the same equation, you can obtain the other two resistors R1 and R2. Okay, what is that? Similarly, R1 and R2 can be obtained. Similarly, R2 is equal to what? Or R1 is equal to what? R2 is equal to what? So this can be obtained. See here. If with this equation you can do anything. You can obtain RA, you can obtain RB, or sorry, you can obtain R1, or you can obtain R2, or you can obtain R3, but just selecting the required terms and calling them as RA, RB, RC. Is that okay with you? So in this class, I've just given you the derivation. Okay, so we will be solving problems using this. Okay, I would like to just, when would this be of help? See, if I ask you how this R1, R2, R3 are connected, you can say they're neither connected in series nor in parallel. If I ask you what is RA, RB, RC connected in, they are connected in such a fashion that they are neither in series nor in parallel. Okay, so then what we have to do? So across AB, if you ask, R1, R3 is in series, R2 would come in parallel with that. Across AC, if you ask, R3, R2 would be in series, R1 would be in parallel with that. That's fine. But you see here, can you do such an operation here? You'll be leaving, you have to leave one of the resistors if you have to look at AB, which is not good when we are finding out the equivalent resistors. Okay, so this idea you will have when we solve problems. Okay,